Nanotechnology, the manipulation of matter on the nanoscale, has emerged as a revolutionary field with transformative potential across various industries. Its ability to engineer and manipulate materials at the atomic and molecular levels opens up a world of possibilities that could redefine medicine, electronics, energy, materials science, and more. The true potential of nanotech lies in its capacity to create innovations that were once thought to be the realm of science fiction. Medicine and healthcare. Nanotechnology holds immense promise for healthcare. Nanoparticles can be designed to deliver drugs directly to specific cells or organs, minimizing side effects and maximizing therapeutic outcomes. Targeted drug delivery systems have the potential to revolutionize cancer treatment and other diseases. Nanoscale imaging techniques could lead to earlier and more accurate disease detection, while nano-engineered materials might enable the creation of artificial organs and tissues. Electronics and computing. As traditional semiconductor technology approaches its limits, nanotech offers new solutions. Nano-sized transistors and circuits could lead to smaller, faster, and more energy-efficient electronic devices. Quantum dots, which are nano-sized semiconductor particles, could pave the way for quantum computing, enabling unprecedented computational power for complex problems. Energy and environment. Nanotechnology has the potential to transform the energy landscape. Enhanced solar cells, utilizing nanomaterials, could make solar energy more efficient and affordable. Nanoscale catalysts could revolutionize the production of clean fuels and reduce emissions from industrial processes. Nanomaterials could also improve energy storage devices, like batteries, making renewable energy sources more reliable. Materials science. Nanotech allows the creation of novel materials with unique properties. Nanocomposites, for instance, combine different materials at the nanoscale to achieve superior strength, conductivity, and other attributes. Such materials could lead to more efficient and lightweight structures in aerospace, construction, and transportation. Water purification and desalination. Nanotechnology could offer innovative solutions for water purification and desalination. Nano-engineered membranes could filter out contaminants and salt more effectively, providing clean drinking water in areas with water scarcity. Textiles and wearables. Nanotechnology is also influencing the fashion and textile industries. Nano coatings can make fabrics water-repellent, stain-resistant, and even antibacterial. The integration of nanosensors into clothing could lead to smart textiles that monitor health metrics and environmental conditions. Environmental remediation. Nanomaterials can play a role in cleaning up environmental pollutants. Nanoparticles can break down harmful chemicals, absorb pollutants, and even remove heavy metals from contaminated soil and water. The true potential of nanotechnology extends beyond these examples, touching virtually every aspect of our lives. While its promises are exciting, ethical considerations and potential risks also need to be addressed. As we unlock the capabilities of nanotech, responsible research, regulation, and public engagement are essential to ensure its positive impact on society. As technology continues to advance, the true extent of nanotechnology's potential remains an evolving story, one that promises to reshape industries, drive innovation, and address some of the world's most pressing challenges.